Right now, as astronomers track the Atlas interstellar candidate through its perihelion passage, something massive has appeared in our detection systems that nobody saw coming. A second object, estimated at nearly 100 times the mass of 3I in the Atlas, just emerged from the solar glare on a trajectory that will intersect with the smaller object's path in less than 4 days. This isn't science fiction, but confirmed observations from three independent space-based telescopes that detected this giant through gravitational microlensing effects it's causing on background stars. And what makes this truly unprecedented is that both objects appear to be decelerating in coordinated fashion, as if they're responding to each other's presence. Today, you're going to learn exactly what multiple observatories have detected in the last 18 hours, why the orbital mechanics of these two objects violate everything we understand about random encounters, and what Brian Cox meant when he posted 2 hours ago that we might be witnessing either the most extraordinary coincidence in astronomical history or something that forces us to reconsider fundamental assumptions about interstellar visitors. I'll separate confirmed measurements from early speculation, show you the numbers that have researchers triple-checking their calculations, and explain why the next 96 hours could reveal whether we're seeing natural phenomena or something else entirely. What's confirmed is this sequence of detections that began yesterday at 0215 Universal Time. The Solar and Heliospheric Observatory's LASCO coronagraph captured an anomaly moving through its field of view that operators initially dismissed as a software glitch. The object appeared too large and too faint simultaneously, suggesting either instrumental error or something with unusual optical properties. Within 4 hours, the Solar Dynamics Observatory detected gravitational lensing of background stars consistent with a massive object, where SOHO saw the anomaly. The clincher came when Parker Solar Probe's wide-field imager captured the object eclipsing multiple stars in sequence, allowing precise calculation of its size and trajectory. The numbers are staggering but verified. This new object measures approximately 300 kilometers across based on occultation timing, making it larger than most main belt asteroids. Its mass, calculated from gravitational effects, exceeds 10 to the 18 kilograms, roughly 100 times more massive than typical cometary nuclei. The object is moving at 47 kilometers per second, clearly above solar escape velocity, confirming another potential interstellar visitor. But here's where things get strange. Its trajectory brings it within 2 million kilometers of where 3I Atlas will be in 91 hours, and both objects have shown synchronized deceleration of 0.3 meters per second squared over the last 12 hours. The orbital mechanics tell an impossible story. Two random interstellar objects shouldn't arrive from the same region of sky within weeks of each other. The probability is less than 1 in 10 billion based on known interstellar object density. They definitely shouldn't show coordinated velocity changes without direct interaction. The larger object's trajectory traces back to the same stellar neighborhood as 3I Atlas, somewhere in the direction of Lyra, but offset by about 2 degrees. If these objects traveled together, that angular separation implies they have been moving in formation for at least 1,000 years, maintaining spacing across interstellar distances. Brian Cox addressed the situation in an emergency podcast this morning, emphasizing that coincidences do happen in astronomy, but this exceeds reasonable probability. Cox pointed out that we must consider 3 possibilities. First, these objects might be gravitationally bound, essentially a binary system we're only now recognizing. Second, they could be fragments of something much larger that broke apart long ago, but maintain similar trajectories. Third, and Cox stressed, this requires extraordinary evidence. They could be related through non-natural means. He reminded listeners that Occam's razor favors the simplest explanation, but sometimes the universe doesn't care about our philosophical preferences. What changed everything was this morning's discovery of electromagnetic connections. The Very Large Array detected coherent radio emissions between the two objects at 8.4 gigahertz. These aren't random signals, but phase-locked transmissions where each object broadcasts when the other receives. The timing precision exceeds 1 nanosecond across 2 million kilometers, requiring either atomic clock accuracy or quantum entanglement. The signals carry frequency modulation that resembles data packets, though no one has decoded meaningful information yet. Most disturbing is that both objects' emissions intensified the moment the larger one became detectable, as if proximity triggered activation. Let me be absolutely clear about separating fact from speculation here. What's confirmed is that two objects with hyperbolic orbits are approaching each other while decelerating synchronously. What's confirmed is structured electromagnetic emission between them. What's confirmed is that both show non-gravitational acceleration inconsistent with simple outgassing. What some researchers privately discuss is whether we're witnessing a rendezvous between artificial objects. What remains pure speculation is any notion of hostile intent or targeted behavior. The universe doesn't do melodrama, but it does surprise us regularly. The larger object shows characteristics that defy easy categorization. Its albedo, the amount of light it reflects, is less than 1%, making it darker than charcoal. This explains why optical telescopes missed it until gravitational effects revealed its presence. The infrared signature indicates a surface temperature of 290 Kelvin, far warmer than an inert object at this distance should be. Internal heat generation would require radioactive decay or active processes we don't understand. Spectroscopy reveals absorption lines matching no known mineral or ice, though some researchers note similarities to certain carbon nanostructures that don't occur naturally. The timeline of synchronized events raises profound questions. Both objects began decelerating within the same hour, despite being millions of kilometers apart. Both increased radio emissions when the larger object cleared solar conjunction. Both show rotation periods that are mathematically related, with the larger object spinning exactly 3 times for every 5 rotations of 3S Atlas. These correlations suggest coordination, but natural resonances could produce similar effects under specific conditions we've never observed before. Here's the updated trajectory analysis that has everyone recalculating. In 4 days, the objects will pass within 2 million kilometers of each other, close enough for significant gravitational interaction, but not collision. Their combined deceleration brings them to a relative velocity of just 12 kilometers per second at closest approach. After the encounter, models predict they'll either capture each other into a bound orbit or exchange momentum in a gravitational slingshot. Either outcome changes their future paths dramatically. The precision required for this maneuver, if intentional, exceeds our best spacecraft navigation by orders of magnitude. The energy considerations boggle the mind. Decelerating objects of this mass requires enormous thrust. For the smaller object, observed changes need about 10 to the 12 watts of power. The larger object needs 10 to the 14 watts. That's equivalent to the entire power output of human civilization. Chemical rockets can't provide this. Ion drives would need reaction mass exceeding the objects themselves. Solar radiation pressure is 1,000 times too weak. Unless we're missing something fundamental about physics, these objects carry power sources we don't understand. What makes this more puzzling is the apparent communication protocol. The radio exchanges follow a pattern where each transmission contains prime number pulse sequences. First contact protocols designed by our scientists actually recommend prime numbers as universal mathematical concepts any intelligence would recognize. But nature produces patterns too, and pulsars emit with mathematical regularity. The key difference here is adaptation. When Earth-based transmitters accidentally interfered with one frequency, both objects simultaneously shifted to another, maintaining their exchange. That suggests either sophisticated error correction or lucky coincidence. Public reaction has shifted from excitement to concern in the last 12 hours. The phrase targeting trends globally on social media despite no evidence of hostile intent. Government space agencies have released careful statements emphasizing that close encounters between space objects happen naturally, citing recent asteroid near misses as examples. But privately, sources indicate elevated meetings at defense ministries worldwide. The UN Office for Outer Space Affairs called an emergency session. Stock markets show volatility in aerospace and defense sectors. Fear sells, but fear based on misunderstanding helps nobody. The scientific community has mobilized like never before. Every major radio telescope on Earth now monitors these objects continuously. Optical observatories coordinate to maintain 24-hour coverage as Earth rotates. Space agencies are reprogramming satellites to observe the encounter. SETI protocols have activated, though researchers emphasize they're gathering data, not making contact attempts. The International Astronomical Union established a special committee to coordinate observations and control information release to prevent panic or misinformation. Four competing hypotheses attempt to explain these observations naturally. First theory proposes both objects are fragments of a disrupted planet or large asteroid, maintaining similar orbits through shared origin. The synchronized behavior might result from tidal forces or magnetic field interactions. Second theory suggests we're seeing a new class of interstellar objects with exotic composition that responds to solar radiation in unexpected ways. The deceleration could come from asymmetric outgassing of supervolatile compounds. Third theory invokes dark matter interactions, proposing these objects contain or interact with dark matter in ways that produce anomalous forces. Fourth theory questions our measurements, suggesting systematic errors in our instruments or analysis create artificial correlations. But none of these theories adequately explain all observations. Fragment hypothesis fails because the objects show different compositions and internal heat. Exotic ice hypothesis can account for the precise electromagnetic coordination. Dark matter hypothesis makes predictions that don't match other observations. Measurement error hypothesis is undermined by independent confirmation from multiple instruments. We're left with a phenomenon that doesn't fit our models, which either means our models need updating or we're seeing something genuinely unprecedented. The next 96 hours unfold with astronomical precision. Tomorrow, both objects reach optimal viewing geometry from Earth. In 48 hours, they achieve minimum separation from each other while both remain visible to our instruments. 72 hours brings closest approach between the objects. 96 hours marks the point where their future trajectories become clear, either bound together or flying apart forever. Each moment provides data that constrains possible explanations. The universe has given us a deadline for understanding. What Brian Cox emphasized in his latest statement deserves attention. Science has faced paradigm-shifting observations before. Continental drift seemed impossible until we understood plate tectonics. Quantum mechanics violated common sense but proved correct. Dark energy surprised everyone but explains cosmic acceleration. Each time, careful observation and honest analysis revealed truth stranger than fiction. Cox argues we're potentially facing another such moment, where nature shows us something that doesn't fit our current understanding but will eventually expand it. The possibility of coordinated artificial objects can't be dismissed entirely, though it requires extraordinary evidence. If confirmed, it wouldn't necessarily mean active visitors. These could be ancient probes following predetermined programs. They might be von Neumann machines that replicate and spread throughout the galaxy. They could be automated systems that activate near stars for energy or resources. Or they might represent technology so advanced we can't recognize its purpose. But each speculation must be weighed against the far more likely possibility of natural phenomena we don't understand yet. Here's something that hasn't received enough attention. 3 other objects with unusual trajectories have been detected in the last week, though none show the extreme characteristics of these two. Comet C 2025 R2 brightened anomalously. Asteroid 2025 QX3 showed unexpected acceleration. A previously unknown object designated 2025 T7 appeared on a hyperbolic trajectory. While these are probably unrelated discoveries, the cluster of unusual objects has some researchers wondering if we're missing a bigger picture. Perhaps solar maximum triggers phenomena we haven't observed before. Maybe improved detection technology is revealing a previously hidden population. The electromagnetic spectrum tells different stories at different wavelengths. In radio, we see structured, communication-like signals. In infrared, we detect unexplained heat signatures. In visible light, the objects appear nearly black, absorbing rather than reflecting. In ultraviolet, unexpected emission lines suggest exotic chemistry. In X-rays, sporadic bursts indicate high-energy processes. Each wavelength provides a piece of the puzzle, but the pieces don't fit together using known physics. It's like trying to assemble a jigsaw puzzle where some pieces seem to belong to a different picture entirely. International cooperation has been remarkable despite the circumstances. Data sharing happens in real time through secure networks. Observation plans coordinate to avoid duplication and maximize coverage. Analysis software and algorithms are freely exchanged. Even nations with tense relationships are collaborating, recognizing that this transcends terrestrial politics. The closest historical parallel might be the international response to the ozone hole discovery, but this happens much faster and with higher stakes. For context, remember that space is vast and encounters are rare. The asteroid belt contains millions of objects that never collide. Comets pass through the inner solar system without hitting planets. The odds of two random interstellar objects encountering each other by chance are essentially zero. Either these objects aren't random, they're connected through physics we don't understand, or we're witnessing the most improbable coincidence in recorded astronomical history. None of these options is comfortable, which might be why they're all worth considering. The power source question becomes more pressing with each observation. Both objects maintain internal heat without visible solar panels or radiators. They generate radio emissions without apparent antennas. They change velocity without visible exhaust. If natural, they must contain energy storage mechanisms unlike anything in our solar system. If artificial, they represent technology that makes our best spacecraft look like stone tools. Either possibility revolutionizes our understanding, though in very different ways. Amateur astronomers have made crucial contributions despite the object's faintness. One group in Chile captured the larger object's shadow passing over the moon. Another in South Africa recorded brightness variations suggesting surface features or rotation. A network in Japan coordinated to track both objects simultaneously, confirming synchronization. These citizen scientists provide coverage when professional telescopes are weathered out or committed elsewhere. Science benefits when everyone can contribute observations. The question of what happens after closest approach matters enormously. If the objects capture each other gravitationally, they'll orbit their common center of mass while continuing through the solar system as a bound pair. This would provide extended observation opportunities, but raise questions about why they'd rendezvous here specifically. If they exchange momentum and separate, one might be ejected at even higher speed, while the other potentially becomes bound to our sun. That scenario would give us long-term access to at least one object for detailed study. Media coverage has become increasingly sensationalized despite scientists' calls for calm analysis. Headlines scream about invasion or attack without evidence. Social media spreads doctored images and fabricated documents. Conspiracy theories multiply faster than fact-checkers can respond. This noise makes real scientific communication harder, forcing researchers to spend time debunking nonsense instead of analyzing data. The irony is that the real observations are extraordinary enough without embellishment. Here's what would constitute genuine proof of artificial origin versus natural phenomena. Artificial objects would show propulsion without reaction mass, communicate using mathematical or linguistic patterns, demonstrate technology beyond our capabilities, or respond to our signals in meaningful ways. Natural objects would follow conservation laws even if through unknown mechanisms, show chemical and physical processes consistent with extreme conditions, and exhibit behaviors that repeat in other similar objects. Right now, observations fall frustratingly between these categories. The smaller object, our original 3-eye Atlas visitor, has changed behavior since the larger object appeared. Its radio emissions now pulse in response to the larger object's signals. Its deceleration matches precisely despite different masses. Its rotation period has synchronized through some coupling mechanism. These changes happen too quickly for gravitational effects alone. Magnetic fields might explain some coupling, but the distances involved should make such effects negligible. We're missing something fundamental about how these objects interact. Government responses have been measured, but revealing. No military alerts or defensive postures have been activated publicly. Space agencies emphasize scientific opportunity rather than threat. But increased activity at space surveillance facilities is obvious. Diplomatic channels buzz with discussions about planetary defense and information sharing protocols. The UN Security Council received briefings. These actions suggest governments take the situation seriously while avoiding public panic. It's a delicate balance between transparency and stability. The next critical observations happen tonight when both objects are visible simultaneously from Mauna Kea observatories. The Keck telescopes will attempt infrared spectroscopy of both objects to compare compositions. The Subaru telescope will search for smaller companions or debris. The Gemini telescope will monitor for changes as the objects approach each other. These observations should definitively establish whether the objects share common origin or represent independent arrivals. The results will be public within hours of collection. What troubles physicists most is the apparent violation of momentum conservation. Both objects decelerate without obvious reaction, mass, or external forces. Solar radiation pressure works wrong direction. Gravitational drag from solar wind is negligible. Magnetic fields at this distance can't produce observed forces. Either we're missing a momentum exchange mechanism, perhaps through particles or fields we can't detect, or these objects operate using principles beyond current physics. Neither option is comfortable for scientists trained to trust conservation laws. The cultural impact already ripples globally regardless of what these objects actually are. Religious groups debate theological implications. Artists create works inspired by the mystery. Musicians compose symphonies timed to the object's orbital periods. Writers craft stories exploring possibilities. This cultural response reflects humanity grappling with potentially transformative knowledge. Even if these prove to be natural objects, they've already changed how we think about our place in the universe. Statistical analysis of all anomalous observations yields interesting patterns. The radio signals show fractal structure with self-similarity across different timescales. The deceleration curves follow exponential decay towards some asymptotic value. The temperature variations correlate with radio emissions through a complex transfer function. These mathematical relationships might reveal underlying physical processes or could be artifacts of how we're analyzing the data. Distinguishing signal from noise requires more observations. As I speak, the objects continue their cosmic dance toward each other. Every telescope capable of observing them is trained on their positions. Supercomputers crunch orbital calculations trying to predict exact trajectories. Scientists debate hypotheses in real time through video conferences and rapid publications. The entire scientific community watches, waits, and wonders what the next 90 hours will reveal. We're living through a moment that might appear in future textbooks, though we don't yet know which chapter. The engineering implications of confirmed artificial origin would transform civilization. Propulsion without visible reaction mass would revolutionize space travel. Power generation at observed scales would solve energy crises. Materials surviving these conditions would enable incredible structures. Communication systems with such precision would advance telecommunications beyond recognition. But we must resist jumping to conclusions. Extraordinary claims require extraordinary evidence, and evidence takes time to accumulate and verify. Natural explanation remains most likely despite the puzzles. The universe has surprised us countless times with phenomena that seemed impossible until understood. Neutron stars, black holes, dark energy, quantum entanglement, all defied initial comprehension. These objects might represent another natural phenomenon that expands our physics. The synchronized behavior might emerge from interactions we haven't modeled. The power source might involve nuclear processes in exotic matter. Nature's imagination exceeds ours. Tomorrow brings critical observations as both objects reach optimal viewing geometry. The day after tomorrow reveals whether their interaction changes their fundamental properties. 3 days from now determines their future trajectories. 4 days from now, we'll know whether they've bound together or separated forever. Each checkpoint provides data that confirms or refutes hypotheses. Science proceeds through patient observation and careful analysis, not dramatic revelation. The larger object's emergence changes everything about how we interpret 3I Atlas. What seemed like a lone visitor might be part of something bigger. The radio signals gain new context as possible communication rather than random emission. The trajectory correlations suggest intention rather than coincidence. But we must resist the temptation to see patterns where none exist. Human brains evolved to detect agency even where only randomness exists. Science requires us to overcome this bias through rigorous analysis. Whatever these objects are, they've already taught us something valuable. Our detection systems missed the larger object until almost too late. Our models didn't predict synchronized arrivals. Our theories can't explain all observations. These gaps in knowledge represent opportunities for discovery. Science advances when observations don't match expectations. These objects, whether natural or otherwise, push us to expand our understanding. The countdown continues as two objects race toward each other while humanity watches. In 90 hours, we'll know whether they merge, separate, or destroy each other. The universe is about to teach us something profound, though we don't yet know what lesson it offers. Stay tuned as this extraordinary story continues to unfold.